Good evening, class. Good evening, everyone. Good evening, everyone. Am I audible and visible to all of you? And sorry for the delay, there was a technical glitch, and I hope that it has been sorted out. So, am I visible and audible to all of you? Okay. So, can we begin the class? I'm good. I'm good. How are you all doing? Okay, great. Okay, good. Okay, so here we begin. Today, not much is supposed to be done. Only one topic will be done, and its name is Heisenberg uncertainty principle. है ना? So please write down the topic. Heisenberg principle. In short, we'll write down that HUP. Heisenberg uncertainty principle. Okay. So the prime statement of Heisenberg. Wait a minute. That is okay.
It's okay.
Okay. So the statement given by Heisenberg is that we cannot find out simultaneously the exact position and exact momentum of any subatomic particle. Are you getting that? We cannot find out exact position and exact momentum of any subatomic particle. The keyword is what? Subatomic particle. Subatomic particle, okay? That means HUP, Heisenberg uncertainty principle, is valid for microscopic objects only, which are subatomic in nature, okay? So, and he also says that if you will try to find out the position and the momentum of a subatomic particle, any subatomic particle, simultaneously, you will always come across an error. And he also said that delta x into delta p is more than or equal to h upon 4 pi. More than or equal to h upon 4 pi, okay? So I believe that I can write this down as delta x into m delta v is more than or equal to h upon 4 pi. We can further say delta x delta v will be more than or equal to h upon 4 pi m. If you look that, there are certain corollaries of the Heisenberg uncertainty principle apart from that, okay? There is like say delta E into delta T is more than or equal to h upon 4 pi. What I'm trying to say is that whenever two complementary properties you try to find out at the same time, you'll always come across an error. Any two complementary properties. Now, what do you mean by complementary properties? When we say complementary properties, I mean that for example, day and night. If you have a day, you will never have a night. If you are asleep, you are not awake. That means if you have one thing, you will never have the second thing. These things are called complementary properties. Is that okay? So the position and the momentum, they are called complementary properties. Over here, energy and time are called complementary properties. Furthermore, delta x into delta lambda. Lambda is what? Wavelength. is more than equal to lambda square upon 4 pi. Achha, one more thing you should be noting down that in sometimes h upon 2 pi, this h upon 2 pi is also called h bar. So these things will go a long way because they can ask you anything. Sometimes they can give you that whether this statement is correct or not, delta x into delta p is more than or equal to h bar upon 2. Will it do that? Will it do that? Will it be correct? If I write down this bar, h upon h bar by 2. Can I say that? Yes, I can say that. So be careful with that. Be careful. Now, one more thing. Please understand this thing. It's very, very important. That HUP is the core principle of quantum mechanics. Very, very important. I mean that if I say that quantum mechanics is basically built on multiple concepts. If I have to pull one brick in this castle of quantum mechanics, if I pull that brick, it will all come down. The quantum mechanics come down. What that brick will be? That brick will be Heisenberg uncertainty principle. Secondly, this HUP is direct consequence of wave particle duality. If you remove wave particle duality, then this Heisenberg principle also goes down. Say, for example, why I'm saying so, the question Heisenberg was posing in front of the scientific community was that, see, as far as Niels Bohr was concerned, he said there is a nucleus and there is a clean path of electron. It will revolve in a circular orbit, and we can find the radius. We can also find out the momentum. The radius is given as 0.529 into n square by z, and we have got mvr equal to nh upon 2 pi. Everything was fixed. We could have the energy also minus of 13.6 into z square by n square. So according to Bohr, this world of atomic world was still a world of certainty. Everything could have been found properly and incredibly truly. But after the arrival of de Broglie said, sorry to say that the circle is not the predetermined path of electron in an atom. He said, at best, electron can move in the form of wave. And if that is the case, in that case, this fixed orbit doesn't exist, because if I ask you to find out the position of the particle, you will say, yes, I can find out the position of a particle. You can find out the position of particle with certainty. But what if I say that electron is a wave? Now see, for Niels Bohr, electron was a particle. So it was easy to find out the position of particle in an atom. But when you say it is a wave, boys and girls, tell me, where is the electron? Where is the electron? Here or everywhere? When electron is a wave and it is everywhere, I believe. Yes or no? We have done that last time, that electron behaves as a standing wave. It is everywhere. We are not able to find, we cannot point that electron is here or here. It is everywhere. Now if I ask you from here to find the position of electron, you are actually uncertain. It will be here, there or where? No, we have got no idea. Are you getting that? So you can find the position of a particle but not of wave. You can have the momentum of a moving thing but not of static thing. Since we are not born with the gift to see a particle and a wave together, but if we want to measure the position and the momentum together, we'll always come across an error. Are you getting it, all of you? This defect cannot be eliminated. Even if you are giving the best of the precise instruments, they will remain. They will simply remain. Universe says that you are most welcome to find out the mysteries of my microscopic world. But more you will peep into it, the more fuzzy it will become. It will say there is a limit for you people to look into the microscopic world. After that limit, it's a goodbye. You simply cannot know more than a limiting sense. Are you getting it? What I'm saying is that if you want to know the position of electron, you will have to stop it. You will have to stop it. You will stop it. You will get the position, but you will lose the wave nature. You will lose the wave nature of electron. The moment you allow it, it is again a full wave, and now you have lost the position. Are you getting it? You will have the momentum, but you will have lost the position. Are you getting it, everyone? So either we can have position or we can have momentum. We cannot have both of them together. And it's not a problem of the instruments. We are born with this problem and we'll die with this problem. This problem cannot be eliminated. Okay? So what I'm saying is that in the real world, in our macroscopic world, suppose there's a moving truck. So I am out here. My eye is this, I'm out here. So when a photon comes, strikes the truck and reaches my eye, I'm able to know the position of the truck properly. And the truck is not moved by the photon. The incoming photon is not able to move the truck. So I know the speed as well, the position as well. But when I'm in the microscopic world, the problem is that I have to use light to know the position of electron. Suppose this is the position of electron. Also, this is the position of electron. A photon will come, will strike it, and will come into my eyes. I will be able to know that electron was here. But by the time this photon reaches my eyes, after reflection from the electron, this electron will have moved. A photon cannot move a truck, but a photon can move an electron. They are almost having a comparable weight. Is that clear? So once this electron is moved, I do not know the position of electron now, and I have got lesser information of the momentum as well. Are you getting it? All of you, let me know that. So we are born with the problem that we can either have the position or the momentum. We cannot have both of them. The moment we try to have both of them, we are in all kind of problems. Okay? Okay. So when you try, if I give you a meter scale to find out the position of electron, will you be able to find out the position of electron with the help of meter scale? No, not at all. If I give you a kilometer scale, even the bigger scale, will you be able to find out the position of electron in an atom? No, again. So you need something of a similar scale to find out the position of electron, and that scale is called scale of light, the wavelength of light. And understand, boys and girls, that suppose this is the wavelength of the light, this is lambda, then also this is also the delta x. The maximum accuracy a wave can measure the position of any subatomic particle is its wavelength. So this wave will come back to me and will tell me, sir, I have found the position of electron, but I'm not exactly certain, but I can tell you that electron is between this to this range. And that will be called uncertainty in the position. Similarly, we can have, say, a bigger wavelength. A bigger wavelength definitely will have this much as the lambda. This will also come back to me and tell, sir, I have found the electron, but the problem is that the range of electron is between this and this. This is the uncertainty in the position of electron from the point of view of this wavelength. Is that clear? So if you want more accuracy in the position, which light you will use, the first one or the second one? Which wave you will use? If you want more accuracy in the position, you will use first one or second one? Will use first one. Yes, very good. Smaller the wavelength, better the measurement. Smaller the wavelength, better the measurement. Very good. Very good. Acha, one more thing before I come back over here. See, boys and girls, delta x into delta p is more than or equal to h upon 4 pi. So if I go with the equality sign, if delta x is 0, that means uncertainty in the position is 0. So can I say that uncertainty in the momentum will be infinity? I will have got no idea of the value of momentum. Yes or no? Very good. So delta p will be equal to h upon 4 pi into delta x. This is equal to h upon 0. Anything which is 0 divided by that thing will be giving me infinity. Yes or no? So if I'm having a 100% information, accurate information of position, I will have got 100% non-information or misinformation of momentum. That means certainty in one thing will induce uncertainty in the other thing. More is the value of delta x, lesser the value of delta p, and lesser the value of delta x, more the value of delta p. If you are more certain about the position, you are less certain about the momentum, and vice versa. Is that clear? Is that clear? If the uncertainty in the momentum is 0, then the uncertainty in the position will be infinity. All of you. Good one. Very good. Very good. Very good. So I come back over here. So can I say if delta x is 0 means delta p also infinity? हाँ, बिल्कुल सही है. Correct. Kusuma, very good. I mean, if one of them is 0, other will be infinity. If you're certain, 100% certain about one thing, maybe delta x, then you will be 100% uncertain about the delta p. And if you're 100% certain about delta p, then you will be 100% uncertain about delta x. Clear? Okay, good. So can I say from this discussion that if delta x, if lambda is high, then delta x is also high, and in that case delta p will be low. Uncertainty in the momentum will be lesser, and if lambda is smaller, delta x is also smaller, and that means delta p will be more. Getting it? So I have a question for you people out here. I have a question for you people, and the question says delta x will be maximum in case of first one, violet light, second green light, third blue light, fourth red light. Come on, delta x will be maximum in which case? Very good. No. Are Rutvika, please be careful. Red, I mean, if I go in Vibgyor, as I proceed from left to right, the lambda keeps on increasing. So violet has the minimum lambda and red has the maximum lambda. If lambda is bigger, delta x is also bigger. So it should be red. It should be red. And if I say that delta p is maximum, then in that case what will happen? If you want delta p to be maximum, you should use lesser lambda. Answer will be violet. Yes or no? Good. Very good. Great. Okay, done. Chalo, see. So that being done, so can we move on to some questions right now? So let me ask you a few questions. I mean, this uncertainty in position is high, then uncertainty in the momentum will be low. True or false? True or false? If one of the uncertainty is high, other will be low. True or false? True. Very good. Can I say that Heisenberg uncertainty principle is the core principle of quantum mechanics? True or false? True. Okay. So can I say it is a direct consequence? Heisenberg uncertainty principle is direct consequence of wave-particle duality. Is a direct consequence of wave-particle duality. And we all know that wave-particle duality have significance, have meaning only in the microscopic world. In our macroscopic world, there is no significance of wave-particle duality. In our world, wave is a wave, particle is a particle. A particle cannot behave like a wave. So can I say Heisenberg uncertainty principle is valid in microscopic world only? True or false? Heisenberg principle is valid in microscopic world only. True or false? This is true. So I cannot apply Heisenberg principle on a moving truck or a moving ball. Okay? That is better. Okay, chalo. Now see this thing. Question I am giving you. If delta x is equal to delta p for an electron, an electron in an atom, then you have to find delta x. Can you find out delta x, all of you? Though answering of these questions will be a bit difficult, but we can find it out. Okay, so shall we try? Chalo, aa jao. We all know that delta x into delta p is equal to h upon 4 pi. Since they both are equal and I want delta x, so can I say delta p is delta x? In that case, this will be h upon 4 pi. So delta x whole square will be h upon 4 pi. And if I'm not wrong, let me know that delta x will be root of h upon 4 pi. Yes or no? Will you all agree with that? No. I mean, this m will not come. M will not come. Okay? H upon 4 pi. Okay, now come over here. Second part. This is the first part. Second part I am asking bachcho is that find the value of delta p. Find the value of delta p. I believe delta p will be same. Delta p will be same. Yes or no? Delta x is equal to delta p. So delta p will also be what? Root of h upon 4 pi. Is that clear to all of you? Is that clear? Great. The third one is that find delta v. Find delta v. Come on. Same question. Third part is find delta v. Delta v means uncertainty in the velocity. Come on, boys and girls, be quick. So I believe from here, can I take it from here? This clue that delta p is equal to m, delta v is equal to root of h upon 4 pi. So can I say that delta v will be equal to 1 upon m, root of h upon 4 pi. Root of h upon 4 pi. Good one, very good. Students, I mean, for the electron, this m will be the mass of electron, and if I put that value 1 upon 9.1 10 to power of minus 31 kg, root of 6.6 10 to power of minus 34 upon 4 into 3.14. When you will solve it, you will get this value delta V equal to almost like 8 into 10 to power of 12 meter per second. The uncertainty in the position of electron will be 8 into 10 to the power of 12 meter per second. Is that clear? Remember that for de Broglie, I told you this is not de Broglie, this is basically de Broglie or HUP, Heisenberg uncertainty principle. The units are almost same. For example, that the weight has to be in kg, distance has to be in meter, speed has to be in meter per second, lambda you will measure in meter again, and the kinetic energy or energy will be in joules. Are you getting that? So please don't mess with these units, otherwise you will get the wrong answer. So can we carry forward now? Okay, now see, I asked you a question basically that earlier in the time of Bohr or before Bohr, people were saying that if the electron is a particle, then according to the known laws of physics, this is negative, nucleus is positive, it should fall inside the nucleus. If not directly, according to electromagnetic wave theory of Maxwell, it should spiral down, losing the kinetic energy and fall that way. But we all know that electron does not fall, because if electron falls, it is the end of atom. If it is the end of atom, it is the end of the entire universe as well. Yes or no? So my thing is I'm saying that, so scientists were struggling at that time that why the electron is not falling inside the nucleus. My point is now that even if electron falls inside the nucleus, it will hell up the fire, get out of the nucleus. It is impossible to contain the nucleus because of Heisenberg uncertainty principle. This principle says that if you say an electron is static inside an atom, it is a meaningless thing. Nothing is static in that microscopic world. That microscopic world is buzzing with all kind of terrific activity, all kind of terrific energy. You cannot simply say, electron, please sit down. You can sit down, electron will not. It is born with the everlasting energy, never to settle down. Are you getting it? The more you try to control it, the more it will have energy and it will try to break all the prison. all the prisons you like to contain the electron into. See that what I'm saying? Let us say that. Let's say we are assuming that this is the nucleus and the radius of nucleus is of the order of 10 to power of minus 15 meter. Will you agree with me or not? We have done it earlier when we were doing Rutherford. So that means delta x, uncertainty in the position of electron, will be 10 to power of minus 15 meter. Yes or no? Okay, then according to Heisenberg uncertainty principle, delta x into delta v is equal to h upon 4 pi m. This delta v must be h upon 4 pi m into delta x. Yes or no? Now h is 6.6 10 to power minus 34. And 4 into 3.14, m is 9.1 10 to power of minus 31, and this delta x 10 to power minus 15. When you will calculate that, you will get uncertainty in the velocity as almost like say 10 to power of 12 meter per second. Now this is impossible. This is impossible. Yes or no? Because according to the general theory of relativity, nothing can travel faster than the light. This speed is simply impossible. That means if this is impossible, whatever I was assuming that electron is inside a nucleus is also impossible. What I'm saying is that the bottom line of this statement is that if you will try to put the electron and try to conceal in this much range, it will move out of this range with the velocity of 10 to the power of 12 meter per second. It is impossible to contain the electron. Even if it wants to fall inside, it will definitely go, but will zoom out of it. Will zoom out of it. Electron is a wave. Electron is a wave, and a wave can zoom past anything. Are you getting it? All those problems that it should fall inside the nucleus, they all arise because we assume electron is a particle. If it is a particle, purely particle, it should fall inside it. No doubt about it. No one can stop it. But the phenomena that electron is a wave, it keeps on moving, zooming around the nucleus. If it cannot, you cannot bound it. Is that clear to all of you? Yes or no? Yes or no? So, okay. Now, let's do one more question. So, this is all regarding the electron. Electron in an atom. Electron in an atom, they're saying that delta x is equal to wavelength of electron. Which wavelength? De Broglie wavelength. De Broglie wavelength. Right? If delta x is equal to lambda of electron, wavelength electron, then find percentage of uncertainty in velocity or the speed. Chalo, let's do it. We all know that delta x into delta v, we're doing it correct? Yes, is equal to h upon 4 pi m. And delta x is what? Lambda electron. Lambda electron delta v is equal to h upon 4 pi m. According to de Broglie, we all know that lambda is equal to h upon mv. Yes or no? This is the wavelength of electron. And if that is the case, I believe lambda of electron can be written as h upon mv into delta v equal to h upon 4 pi m. M and M cancel, H and H cancels. So I'm left with delta V upon V equal to 1 upon 4 pi. Yes or no? Now this is called uncertainty in the velocity. And if I want to find out percentage of uncertainty in the velocity, this thing will be written as what? This thing will be written as delta V upon V into 100. The uncertainty upon the velocity into 100 is called percentage in the uncertainty. Is that clear? So I should multiply by 100. Multiply by 100. Very good. So delta V upon V into 100. 100 upon 4 pi. I am multiplying by 100 on both the sides. This will become percentage in the uncertainty in the velocity, and this will be equal to approximately 8% beta. Because 4 and 3.1 is almost like say 12 point something. 12.4. So 100 by 12.4 will be almost 8%. Very good. Marcus, very good. Neil Marcus has given the correct answer. Great. Chalo aa jao. Okay. 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 Okay, let's do one more question. And that question says that Acha, one more thing. If they give you wavelength of light, है ना, to find out the position of electron, what they are giving you directly or indirectly. If they give you lambda of the light, what they are giving you? Directly, indirectly, what they are giving you? Delta X. Very good. Very good. Delta X. They are indirectly giving delta X. We have done that, na beta? That if this is a light and this is a lambda, this is also what? Delta X. So whenever they give you value of the wavelength of a light which is sent to search the electron, they are actually giving you delta X. Is that clear to all of you? So I'm giving you a question. Question says that lambda of photon which is sent in search of an electron is given as 0.1 angstrom. 0.1 angstrom. Okay? They're saying find delta V. Delta V of electron. This is for electron in an atom. Chalo batao. So once they have given this thing, so lambda of photon is equal to actually delta X equal to what? 0.1 angstrom. I want the units in what? Meter. So can I say this will be 0.1 into 10 to power of minus 10 meter, which is nothing but 10 to power of minus 11 meter. Will you all agree with me? Will you all agree? And if that is the case, I believe that delta X into delta V is equal to H upon 4 pi m. Now, you know almost everything. Delta V will be H upon 4 pi m and divided by delta X. So 6.6 into 10 to power of minus 34 upon 4 into 3.1 into m, 9.1 10 to power of minus 31 kg, and delta X will be 10 to power of minus 11. Weight has to be in kg, distance has to be in meter at any cost. Okay, and if that is the case, so let me know what is the value, approximate value. This will be gone, this will be 10 to power of minus 3, and this will be gone 10 to power of 8, I believe. But so this is 12 and this is 6.6, almost 6, this is 12. So can I say roughly that this will cancel with 2 times? And 9.1 into 2 is 18. Approximately 18 can be written as what? 20? लिख लेते हैं यार, क्या दिक्कत है? Will be now, this will be 10 to power of 8 upon 20. Approximately this will be 100 into 10 to power of 6 upon 20. This will be 5. So my side, the answer is approximately 5 into 10 to power of 6. Delta V, that will be meter per second. The exact answer is 5.6 or 5.7. So almost there, bacho. They will not play with this. They will not give 4.7, 5.7, 10 to the power of 6. No, they will play with the power. Only one option will be there with the power of 10 to the power of 6 in NEET, in general. Neil Marcus, check it out. It will be 10 to the power of 6. Check it out. The rest of you, please confirm the answer. Please confirm the answer. Be quick, bacho. Come on, be quick. Okay, great. Very good. Very good. Now, students, just understand. If you go by the Heisenberg uncertainty principle, Heisenberg said that it is almost impossible, not almost, it is actually impossible to get the clear picture of the atom. Yes or no? Because if you want the position, you will get it, but you will lose the momentum. You want momentum, you will get momentum, but you will lose the position of electron. Because electron has a dual nature. It is a direct result of wave particle duality. And we human beings are not born with the gift to see wave and a particle nature of a same thing at the same time. So since we can't see both of them at the same time, how can we measure them with so much of accuracy at the same time? Are you getting it? You can measure only what you can see. I can see either a particle or a wave, not both of them. So idea is that we simply cannot have an idea. So I mean, from now onwards, if someone will ask you, but draw the structure of atom, so what you will say? I mean, is this a structure of atom is okay with you? That number of orbits, number of electrons revolving like that? Is that so? Will you agree with that? This is simply a mental model to get some idea of hydrogen spectrum, not more than that. So this thing too does not exist. This thing does not exist, है ना? Okay. Okay. Wait. Is it okay now? Is it okay? Am I audible? Okay, what I'm saying, we'll be doing a question on golf ball. Golf ball is a macroscopic object, and you have told me that all these things are not valid on the macroscopic objects. So let us see that why it is not valid. Peter, which one you want to be explained? This one, Neil Marcus. What, Peter? What I need to explain again? This question or what? Be quick. Okay, come over here. So the idea was that the Heisenberg principle is valid only for the microscopic object, not for macroscopic objects. In the macroscopic object, like for golf ball, the result will be like very, very insignificant. So let us verify that. They're saying the weight of the golf ball is 40 gram, the speed is 45 meter per second, and it can be measured. What speed can be measured with an accuracy of 2%. That means uncertainty is what? 2%. Okay, chalo. So find delta x. Chalo dekhte hain. So let us find out this thing. Delta V upon V into 100 is given